In this lecture, I'll show you how to install and use IPFS on Windows. So first, we must go to ipfs.io/docs/install. There, we click on Download IPFS for your platform. There are some IPFS binaries for different distributions, for FreeBSD, for Linux, and so on. We'll choose the Windows binary, the AMD 64 version, if we use a 64-bit operating system. Windows 10, for example, is a 64-bit operating system. So the IPFS has been already downloaded, okay, and now I go to download folder, and here we have the zip archive. I'll extract the content of this archive, and to be easier, I'll drag and drop the directory to the desktop. This is the directory that contains the IPFS binary. This is IPFS, ipfs.exe. Now I'll open cmd.exe, so the command prompt, and I'll drag and drop the ipfs.exe to this window here. The first step is to initialize IPFS by creating a key pair and by initializing the local repository, so IPFS init. This command creates or generates a RSA key pair and initializes the local repository. For example, this is our identity. This is the identity of this IPFS peer, this hash from here. Okay, IPFS has been initialized, and now we can start the IPFS daemon. So, one more time, I'll drag and drop the ipfs.exe here and daemon. Okay, allow access. And the daemon started successfully. So daemon is ready. Now we can offer or we can share content to IPFS. I've dragged and dropped the ipfs.exe to the command prompt. Another possibility is to add ipfs.exe to the Windows path. If I don't add ipfs.exe to the Windows path, I can't simply write IPFS because IPFS is not recognized. Let's add a directory to IPFS. I'll change the directory to C local drive, and here I have a directory named IPFS project. This directory will be added to IPFS, and inside this directory there are two files, a text file and an image, a.png. So let's add this directory to IPFS. One more time, I'll drag and drop ipfs.exe and add -r. -r means recursive, and now the name of the directory. The directory and its content has been added, and these are the hashes that represent my directory and my files. For example, if someone from the internet wants to access my file, he must use an IPFS gateway and this hash. For example, let's open the browser, and in a new tab, let's request the files from the main ipfs.io gateway. So ipfs.io/ipfs, and now the hash of my a.png file, for example. So I'll select the hash, copy, and paste it here. And we can see the image, the PNG image. My image belongs now to IPFS, to the interplanetary file system. What happened? The main IPFS gateway, so the gateway from ipfs.io, connected to my IPFS gateway, to this application, to this daemon, and requested the file using its hash. Then the file has been transferred to that gateway after it has been chunked in many parts, and the gateway sent the file to the client, to the browser. We can also access the localhost web interface So localhost, the port is 5001, web UI from user interface. And this is the IPFS web interface. We can see here many details like peer ID. We can see here our network addresses. So our IPFS daemon listens on these addresses from here. We can see here our IPFS peers. So at this moment we are connected to 749 peers, and these are the identities of our peers. The peers can also be seen by using the IPFS swarm peers command, so something like this. So IPFS swarm peers. These are my peers. Okay, this is how we install and use IPFS on Windows. As a conclusion, I must say one more time that saving data on Ethereum blockchain is very expensive. We'll save our data using IPFS, and in our smart contracts we'll only save the file hash as a state variable. So the hash of the file is saved on the Ethereum blockchain and the file content is saved on IPFS.